Hi guys, today class agenda is how deep learning is important for artificial intelligence and data science. So we can say that deep learning is an important element of data science which includes statics and predictive modeling. So with the help of deep learning we can go for statistical analysis and predictive modeling, right? So in other terms, it is extremely beneficial to data scientists who are tasked with collecting, analyzing and interpreting large amount of data. Large amount of data means maybe data in terms of structure form, maybe data in the form of unstructured form, right? And in terms of deep learning makes this process faster and easier. At the simplest, deep learning can be thought of as way of automate predictive analytics. In some other terms, you can say that while traditional machine learning algorithms are linear, deep learning algorithms are stacked in a hierarchy of increasing complexity and abstractions. So in terms of definition, deep learning is a branch of artificial intelligence that imitates the way of human gain certain type of knowledge. That means it's totally based on human knowledge, right? In other aspects, deep learning is a machine learning technique that teaches computer to do what comes naturally to humans, and it's always learn by example. Or in some other words, deep learning is a key technology behind driverless car. That means enabling them to recognize a stop sign, brake signs and all the other signs related to human car. It is the key to voice control in consumer device like phone, like tablets, like TV, and there are a lot of hands-free speakers. Or there is one more additional advantage of deep learning. Deep learning learns is getting lots of attention lately and good for many good reasons, and it is achieving results that were not possible before. That means before deep learning there is a machine learning techniques on the basis of classification and regression, but in case of deep learning the accuracy is very high compared to machine learning, right? In this example you can see there are 3 to 4 levels of deep learning. With the help of this car, the first level is low level features, second one is middle level features, third one is high level features, and final features is called trainable feature. That means trainable classifier. That means finally we got the proper and exact classifier with the help of deep learning. So in this diagram you can see the performance of your deep learning. Suppose we have huge data may be terms, I'm talking about big data, and data there are 3 to 4 ways of data, maybe in the structured form and maybe in the unstructured form. So you can see in this diagram the amount of data is very high, and the case of performance is very high in case of deep learning in compared to other and traditional techniques like machine learning or classification and regression. The performance is very low. So in terms of performance, deep learning is very accurate and very high in case of huge data. So in the next task, why deep learning matters. So it's very important in terms of deep learning. It's a very frequent and common keyword in case of data science or artificial intelligence or machine learning, that is called accuracy. So deep learning achieves recognition accuracy at higher level than ever before. That means the accuracy of deep learning is very high in compared to other traditional methods. This helps consumer electronics meet user expectation, and it is a crucial for safety critical application like driverless cars or some other application is based on deep learning. So there are another additional advantage of deep learning in case of like algorithmic improvements. That means it have boosted the performance of deep learning methods. Another one, that means new machine learning approach have improved accuracy of model. That means with the help of deep learning we can easily match the accurate data and then we can generate perfect model with high accuracy. And the next important aspects, that means in case of new classes of neural networks have been developed that fit well for application like text translation and image classification, or we can say that In case of translation and image classification, deep learning is very important because deep learning is purely based on neurons. Another aspect, suppose we have a lot more data available to build neural networks with many deep layers. Deep layer means many hidden layers, including streaming data from Internet of Things and textual data from social media and some other kind of data. That is very helpful. Another advantage, that means computational advances of distributed cloud computing based on hybrid cloud, based on private cloud, and graphics process units have put incredible computing power at our disposal. And in terms of example, there is a lot of example of deep learning. The first one is automatic driving. So automatic driving is a different kind of approach in case of deep learning. That means with the help of automotive, researchers are used deep learning to automatically detect objects such as stop signal and traffic lights. In addition, deep learning is used to detect many different layers of automatic driverless car, which helps decrease accidents with the help of these techniques. The second is another important aspect of deep learning, that is called aerospace and defense. So in this case, deep learning used to identify objects from satellites that locate area of internets and identify safe or unsafe zone for drops. That is a very important aspect of machine learning in case of our defense, and there are many organizations like DRDO also use this kind of techniques. And third, that is called medical research. In this field, again, deep learning is play a very important role. Like in case of cancer, researchers are basically use deep learning to automatically detect cancer cell. That means in example of this case, that means teams of UCLA build an advanced microscope that yields high dimension dataset used to train a deep learning application to accurately identify cancer cells. Right. So in another aspect, that is another example in case of deep learning, that is called industrial automation. In this case, deep learning is helping to improve worker safety around heavy machinery by automatically detecting when people or objects are within unsafe distance of machines. That means with the help of these techniques, we can improve our industrial automations. And the last and the very good another application of deep learning, that is called electronics. So in case of electronics, deep learning is being used in automated hearing and speech translation. For example, home assistant devices that respond to your voice and know your preference are powered by deep learning application. So that is very important aspect of deep learning, right? So how deep learning works, it's another very important aspect of machine learning. That means machine learning or deep learning, that means how deep learning works. So most deep learning methods are used neural networks. That means it's about network to network, there is based on network topology. So that means neural network architecture, which is why deep learning models are often referred as deep neural networks. So in this term, there is a keyword, and keyword is called deep. Deep usually refer to the number of hidden layers in the neural network. In other aspect, the traditional neural networks contains only 2 and 3 hidden layers. But in case of deep learning, we can have more than 150 and near about 200 layers of neural networks, right? Or we can say that in case of deep learning, models are trained by using large set of labeled data. Labeled data means you know each and everything about data, and neural network architectures that learn features directly from the data without the need for manual feature extraction. This is the key aspect of deep learning. So you can see in this diagram, suppose we have 3 inputs and there are 3 input layers of deep learning, and again we have generated hidden layers. There are a lot of hidden layers of machine learning, maybe 2 layers, maybe 3 layers, and after that we can generate your output layer, and we can generate your output with the help of deep learning algorithms. So you can see in the diagram. So in this diagram, we can say that neural network, which are organized in layer consisting of a set of interconnected nodes, or we can say that network can have 10 or 1000 of hidden layer. That's why just because of hidden layer, neural network or deep learning is very popular in these days. Now, in another aspects, a CNN convolves learned features with input data and uses 2D convolution layers. That means 2D layer is very important because with the help of this layer, making this architecture well suited to processing 2D data such as images. So you can see in this image there is an input image, and input image is just like a flower. So now we can generate our models on the basis of CNN. So it's in first layer, that is generate convolution, that means in other aspect that is called rectified linear units, and then third one is pooling. So we can generate, there are 3 to 4 types of pooling: pooling 1, pooling 2, pooling 3, and pooling 4. That is all about your hidden layers. And after that we can generate your FC means fully connected layer to support classification. So it may be flower, it may be cup, it may be car, it may be tree. In the second aspect of this figure, we can just filter light and dark on this image, and we can slide the window over the input image and then generate the next aspect, the simplest shape, and then after that we can just mod it into complex shapes. And after that, shapes that can be used to define a flower. That means with the help of this shape we can just mention the outlook of your image and outlook of your image that is pretty much similar to your flower. After that we can just generate multiple models like x1, x2, x3, then generate your FC means fully connected layers to support classification, and then generate your models, that means hidden models, and then we check the probability of your input image, maybe flower, maybe cup, maybe car, maybe tree. So you can see in this diagram the probability of flower is very high. That's why this input image is flower. That means in this case every features map output the result of applying a filter to the image. That means the activation of your network at particular level, right? So example of a network with many convolutional layers, filter are applied to each training image at different resolution, and the output of each convolved image serve as a input to the next layer. So with the help of this diagram we can predict the input image is a proper flower, not to be cup, not to be car, not to be train, not to be tree, just because of neurons. That means convolution method or CNN. So in next aspects, why deep learning is better than machine learning. So there is a lot of difference between deep learning and machine learning. So deep learning is a specialized form of machine learning. A machine learning workflows start the relevant features being manually extracted from images. So there is a key difference between deep learning and machine learning, and the features are then used to create a model that categorize this object in the image. With a deep learning workflow, relevant features are automatically extracted from image. So in addition, deep learning performs end-to-end learning, while a network gives a raw data and a task to perform such as classification, such as regression, and it learns how to do this automatically. In other aspect, the key difference is deep learning algorithm scale with data, whereas shallow learning coverage. Shallow learning refer to machine learning methods that for a certain level of performance which you add more example and training data to network. So the key advantage of deep learning network is that they often continue to improve. The size of your data increase. That means whenever your data size is increased, that means the model or your deep learning performance is much better, right? So in other aspects, in terms of data size, deep learning does not perform well with a smaller data set, but machine learning algorithms can process a small data set. That means suppose we are working about big data, that means in that case deep learning is much better. But in case of suppose we are working on small data, that means minimum 5 observation and 25 data points and 25 to 30 observation. In that case machine learning is better option in case of machine learning. Second aspect, in case of execution time. So in case of execution time, it is easy to assume that deep learning algorithms will have a shorter execution time as it more more developed than a machine learning algorithm. That means your algorithm process is quite fast in compared to machine learning. You can see in this diagram, in case of machine learning is basically use manual feature extraction. Suppose in this diagram 1 is a car, that means with the help of manual feature extraction, and there is some techniques of machine learning, maybe classification, maybe regression, and some other techniques. We can easily predict the input image is car, is not a truck, is not a bicycle. But in case of deep learning, the approach of your model is entirely different. In that case, suppose there is an input image is car, so we can apply a CNN model and we can extract multiple images, multiple features, and or we can say that is learned features. That means we can pass multiple layers and check the input image is car, truck or bicycle, and the accuracy on the basis of percentage, maybe 95% features is matched to car, that's why this is a car. So in terms of accuracy, deep learning accuracy is much better than machine learning.